And now to talk about casting. I know I've used this a few times and kept saying we will go over this later, and finally the time has arrived. Let's talk about casting. Casting took me a long time to figure out, mainly because I was trying to figure it out before I learned about inheritance, interfaces, and extendable classes, which is why I waited until now to talk about casting. So what does casting mean? Casting means you can assign one data type to another data type as long as that data type is a subclass of the other data type. I know I just use data type a lot. All standard and custom objects are S-objects. So to use S-objects as the example, or as one of the examples, is why we can do the following. If we have a list of S-objects, we'll call it S-object list. And then we'll do a new list. Semicolon. And then we will add to the list an account and a contact. So add a new account, and then we'll create name equal to test account, and then add a contact, add new contact. We'll do first name test, need a single quotes, and last name contact. Now when I run this, everything runs and I'm able to insert, we'll debug. S-object list. So I'm able to, in this list, put the account and contact, which we've seen before. And the reason being is that an account and a contact is an S-object. And because accounts and contacts are S-objects, they inherit everything from the S-object, and we can put them into an S-object list. So at the moment, the account and contacts, the data type for them, because they're in this S-object list, is S-object. And because of that, we can do the following. So I can take an account, we'll have a new account, we'll then take from the list, we'll take the first index. So this will fail. And as we can see, illegal assignment from S-object to account. Because it's in the S-object list, the data type for that, even though it is an account, is an S-object. And that's where we can then cast. So we were able to cast the account into the S-object, and now we can cast the account back. So from an S-object to an account. And then let's debug the account. And everything worked, and when I debug the account, I can see the account in there. So I can do the same thing with the contact. So I can do contact con, and then cast the S-object into a contact. And then use the second index, which would be number 1. And we can debug. And run. And when I run, I can see the account and I can see the contact. So the one thing that we cannot do is we cannot take this account contact and turn it into a contact. If I do contact, we'll do con1 is equal to account, or no, not account, I'm sorry, contact. We'll cast it into a contact, but it's going to be the first index, which is the account. So I get an error. Invalid conversion from runtime type account to contact. So we learned about S-objects and accounts, contacts, custom objects, and how they're S-objects a long time ago. And we did some casting of those, and we could have talked about casting a long time just with that. However, I wanted to wait until we went through extensions and interfaces to show what else you can do with casting and how casting can come into play aside from just S-objects and creating an S-object list and being able to insert multiple types of S-objects with one list. With casting, you have the ability then to do much more when it comes to building custom Apex code and different types of applications for the code itself. And that is where casting comes into play and has that ability to be much more transformative. As an example, we'll go through quite a few examples just to iterate through and to show what we can do with casting and with virtual, abstract, and interfaces. So we can start with the virtual. So one of the virtuals that we had was the simple logger class. And I'll create simple logger, I'll name it the variable SL. And then we can create a new, and instead of it being a simple logger, we had the updated logger, which is an extension of the simple logger. And then within the updated logger, there is a constructor for two strings. So I'll just set setting message, and then the other one I believe was the stack trace. So we'll just setting stack trace. And because we know that the simple logger has the commit logger method, we're able to use that. So we go sl.commit logger, and when we run it, everything runs successfully, and we have the debugs for this method has been overwritten. That was with the commit logger for the updated logger, it was, we put in this debug to state that it was overwritten. So we know that we are using the commit logger from the updated logger, even though we put the updated logger into the simple logger data type and had that variable. The next thing that we can do is we can have an updated logger data type. We'll call it UL. And then we can just cast the SL simple logger variable into an updated logger variable. And then I can run and commit again. So commit logger. Oh, it's not update, it's updated. We run that and we can see both of them commit the logger and they're using the same type of method. So then, because the updated logger extends the simple logger and essentially is a simple logger just with some additional things, that's why we can create the new updated logger and put it into the simple logger, and then do the opposite for taking because we already created it as an updated logger, and we can put it into the updated logger variable. What we can't do is if we have an updated logger data type, and we'll do UL, we cannot create a new simple logger and try to put that into the updated logger data type. And then UL commit logger. If I try to run that, we get illegal assignment from simple logger to updated logger. And that's because an updated logger is a simple logger, but a simple logger is not an updated logger. So the next thing that we can do is we can also do that with the simple logger abstract. So I'll call it SL, and then new, we'll do simple logger abstract extended, and put in setting message, because the constructor takes a string for the message and then it has a super for the constructor that's in the simple logger abstract. So then I can commit the logger, and run. And I don't think that we did, let me just double check. I don't think we had we didn't have any type of debug. I can actually, since it returns the logger, I can debug the log. So if we can run this, we can see that we were able to debug the logger. The one thing that we can't do is if we take a look and see that this class has the debug logger, so it takes in the log. If we try to run that, so if we do sl dot debug logger, and then we'll take this, put that method in so it returns the log. We get an error, which is incorrect signature debug logger from the type logger simple logger abstract. So this class does not have the debug logger, so we are not able to use it, even though we created a simple logger abstract extended, which has that method. We're not able to use it because of that. So what we could do is, if we really wanted to use it, we can cast it back into, let's use the abbreviations. And SL, and then replace these. And we got an error. Oh, because I need to be casting into the correct data type. There. Now if we run, we can see that everything worked and we were able to debug the logger. So that's how you can use casting with abstract and virtual classes. The next thing that you can do is you can also cast with anything that uses the logging interface. That interface that we create, or really any interface that you create, as long as it's implementing or it's inheriting that implementation, you can then put those class data types into the interface class data type. As an example, I can do list. We'll do logger interface because that is the interface that we created. And then I'll do li list, so logging interface list, and then we'll just create a new list. And we're going to take everything that we implemented with the logging interface and we're going to put it into this list, and then we're going to loop through this list and we're going to commit and debug, because that is within the interface. Those are the two methods that we said that we would always have. So that's where we know that anything that's implementing the interface has those two methods. We know the return types and we know the signature themselves. So I'm going to do a logger interface, create the new list, and then we'll do li list.add. And one of them that we had was the simple logger abstract extended. So we'll add that one. We'll change the message so that way it's a little bit easier for us to distinguish. We'll do testing, and we'll do the name of the class with interface. Casting. So even though the implementation is on the simple logger abstract class itself, the extended is inheriting all that, and we can use the simple logger interface still. Now I could, or actually we can't put a new simple logger abstract class itself into there because it is an abstract itself. We would try to construct it and we wouldn't be able to construct it because it's an abstract. However, we can add the updated logger. I'm going to create a new updated logger and then just replace the simple abstract extended with the updated logger. We can't, however, add the simple logger class because this class is not implementing the interface. So when I try to run this, oh, sorry, I forgot that this one, the updated logger, has a string for the parameters. Okay. And now it says we cannot add the simple logger into the logger interface. So now I'm going to comment that out and run it. And that runs successfully. Next thing that we can do is we can loop through this list using the logger interface. And then we'll just do li, loop through li list. And then with the interface, we know that there is the debug logger, and then there is also the commit logger. And then I can run that. And when we run, we can see that we are able to debug the logger and see that the logs were created. And this gives us the ability to have much more dynamic code than if we weren't able to use this type of casting method.